In this video, we will discuss the biggest challenge of machine learning and we discuss some potential solutions. We have previously considered how machine learning can be used to detect whether an email is spam or not. This is an example of supervised learning. In supervised learning, we feed our algorithm with many X-Y pairs, where X are the features of an object and Y is the corresponding label or target. This is the most well understood form of machine learning. However, supervised learning has its challenges, which generally relate to the data. Regardless of how good your model is, if you provide it with garbage data, it will produce a garbage result. This garbage refers to poor data quality. For example, features containing noise or irrelevant features. Additionally, our data could be non-representative. Maybe you want to build a system for the Netherlands, but you're using data from China or the US. This model may not perform well due to the differences between countries. Therefore, you should always try to use representative data. Our data may also contain biases. For example, you may want to deploy a system that works well for men and women alike, but you only have data about men. However, the most common problem in machine learning is that we don't have enough data. In machine learning, usually the more data we have, the better. Is this such a big problem though? After all, we're living in the age of big data, so of course we should have enough data, right? Unfortunately, it is a huge problem and it is not going away anytime soon. Let's discuss why we do not have enough data and some possible solutions. Machine learning algorithms require features and labels or targets. The features X are often cheap and easy to obtain. For example, if you're classifying news articles, you can easily download hundreds of thousands news articles and extract the word counts. You can do that in a couple of lines of code. Great, you think. Problem solved. Now comes the problem. The label or regression target Y is often much more expensive, time-consuming and difficult to obtain. Why? Well, let's think about the news articles and imagine you would like to predict the topic of an article. You would first need to read 100,000 articles and determine their topic by hand. We cannot automate this because this is exactly what we're trying to automate. Typically, what we're trying to teach is something painful. Something we want to automate away because it is difficult, time-consuming or expensive to do. So this is exactly the problem. The label Y is often very difficult to obtain. Are there any alternatives? Until now, we have talked about supervised learning, where we always provide supervision for all examples. So if we have an email, we will always provide the X and Y pair, both the features and the label. But you can also think about an approach called semi-supervised learning. Here you provide the supervision only sometimes. In other words, in some cases you provide the algorithm only with the X and not with the Y, and Y is the supervision signal if something is spam or not. Why would we want to use semi-supervised learning? Well, exactly because X is very easy to obtain, but the Y can be difficult to obtain. Because we have all this X data, we of course want to try and use it. Okay, that all sounds great. So why don't we always use semi-supervised learning? Well, in practice, semi-supervised learning is an active area of research in machine learning that is still developing. It is quite hard to get it to work in an actual use case outside of research. Another approach is called unsupervised learning. This setting is completely different because in unsupervised learning we only have the feature vector x. There is no y, or there may not even be a prediction task at all. So the goal is very different. We typically use unsupervised learning to find some interesting patterns in our data, without knowing beforehand what to find. So what do we mean by that? Consider the example of a web shop. You have access to all kinds of data about your customers. When are they visiting the website? What products are they buying? Etc. Using this data, we may be able to learn something about our customers. However, beforehand, we don't necessarily know what we want to find. For example, we can visualize our customers to find patterns. One such technique is called clustering, where we try to identify groups in our data. Another example of unsupervised learning is called dimensionality reduction. In that case, we have some high-dimensional data, for example, many features, and we want to reduce the dimensionality. Why? Well, such high-dimensional data is very hard to study. If we reduce the dimensionality to 2, we can easily visualize it like the scatter plot on the slide. Now we can find patterns in the data by eye. Finally, you should be aware of an approach called reinforcement learning. It is frequently used to model games, from Go to Pac-Man and to very complex games like Dota or StarCraft. What is it exactly? Well, in reinforcement learning, our algorithm is controlling an agent, and this agent can perform actions. Think about Pac-Man. Pac-Man can move to the left, to the right, up and down. Such actions lead to rewards, which can be positive or negative. If Pac-Man eats a fruit, we receive points. But if Pac-Man touches a ghost, it dies. These rewards are a signal to the agent to indicate how well it's performing. Finally, our agent exists in an environment. The agent can influence this environment by its actions, such as moving. The environment is characterized by what is called the state. Okay, so what is the difference between supervised learning and reinforcement learning? Well, in supervised learning there is no state. Classifying spam or not spam does not have any effect on the system. There are no direct consequences of a prediction because there is no relevant environment. Or we can safely ignore the consequences. Our algorithm simply doesn't care about them. However, in reinforcement learning, on the other hand, there is a very clear environment and actions influence the future. If we move Pac-Man to the left, it brings us closer to a ghost. Later on, this may lead to Pac-Man's death. So it's important for the algorithm to keep track of the environment or the state. So in reinforcement learning, we cannot ignore the state or the environment, but our algorithm really has to take it into account. Let's summarize this video. In this video, we talked about the main challenges in machine learning related to data. We discussed why the most common problem is that we don't have enough data. That is because the labels Y are expensive, difficult, or time-consuming to obtain. There are several alternatives to the supervised learning paradigm. Semi-supervised learning attempts to tackle the data problem by providing the why only for some examples. Another alternative, in unsupervised learning, we don't even have a why. This is a very different setting because we might not even have a clear prediction task. Finally, in reinforcement learning, we can model agents in a game where keeping track of the environment is essential.